Good morning, everyone. Today's driving question is, what are variables? Just a reminder that your date and driving question should be underlined. You will need a sheet of paper to make notes and complete the activities, or your exercise book, a pen or pencil, and finally, no other devices in use should be turned on at the moment, so can you please switch them off? Thank you very much. This is a remember slide and it assesses prior knowledge from your previous lesson. I would like you to read the questions and write the answers only in your exercise book or on your sheet of paper, just the answers only. At this point, I'm going to ask you to pause the recording. Right, welcome back. So question number 1. Sometimes we are given a problem and we are asked to come up with a prediction as to what will happen at the end of the experiment. The name given to this prediction is a hypothesis from your last lesson with Mrs. Samuels. Okay? Something that you can predict what will happen at the end of an experiment. Okay? Number 2. Some qualities of a good hypothesis are something and something. Now, for this answer, you can write a variety of answers, and here are some examples. It must be testable. You must be able to test it. You must be able to predict, have some type of prediction of what you think will happen or occur. It should be able to be explained. So it must have some type of explanation behind the outcome, and also it should be clear, and it should have a statement including if or then or because you want to be able to make it the experiment clear, and the data that's produced from that experiment should be easy to explain and tested by others as well, okay, for accuracy and precision. This is a very cool video. It's an amazing visual aid that explains our driving question. What are variables? Because there's a variety of variables that are tested during an experiment. So watch this video and enjoy. Right. Scientists conduct experiments to figure out a cause and effect of a relationship. What's causing something to happen and what's the effect? What's the outcome? Effect is outcome. So the relationships need to explain, things that are happening or has happened. Now, these relationships allow scientists to make predictions from the experiments that has been conducted. Scientists are be able to make a prediction that they obtain from a given experiment. Now, it's very important, this image here, cause and effect, because when scientists design an experiment, they're trying to find out how one thing will affect another, or how one variable, how one factor will influence another factor. If this one thing increased, what happened to this other thing? Did it decrease? If this one thing decreased, did the other thing remain the same? So it's kind of cause and effect. How is one thing affecting something else? Now, to break this down, these are the different variables in an experiment that scientists will be testing. So you have the independent variable. It's anything that is going to be changed in an experiment. You are going to change something in an experiment. Okay, we're going to see some examples in a minute. Whatever you change in an experiment is known as the independent variable. How I remember this is independent begins with I, and I change obviously begins with I as well. So you have to remember, independent variable is a variable that I will change. Now your dependent variable depends on your independent variable. Your dependent variable is anything that's going to be measured. Okay? Whatever is being measured in experiment. Are you measuring the height of something? Are you measuring how much something weighs? Whatever is being measured is your dependent variable. And lastly, you have your control variables, and these variables are the variables that remain the same because you need to have a fair experiment. Something needs to remain the same so that the conditions throughout the entire experiment are fair, so that your results, you can say that your results are accurate. Okay? So here's an example. Identify the independent, dependent, and control variables in the scenario below. Maggie read that some plants grow better if the soil is acidic. She can't believe that a plant can grow when exposed to acid. So she wanted to figure something out. Will plants grow in acidic conditions? Her hypothesis could have been plants cannot grow in acidic conditions. She could be, that's testable. Now, Maggie decides to test if plants she has will grow better when acid is added to the soil. She puts potting soil in 2 planting containers and transplants 2 of her geraniums that seem about the same size into the pots. She puts the pots in the same location so that they both get the same sunlight each day. So they're getting the same sunlight each day. They're at the same temperature. They're getting the same temperature. And she makes sure that they get the same amount of water. So they're getting a lot of things, these plants that are the same. However, Maggie puts a tablespoon of vinegar in the water she gives to one of the plants. So she's got 2 planting containers, but one has acid, but the other doesn't have anything. So that is something that she's changed in this experiment. As you can see, she puts exactly 1 tablespoon of vinegar in the water she gives to one of her plants. So one has the acid, one doesn't. So here we can see she kept a lot of things the same for her plants to grow. She also had 1 tablespoon of vinegar in one plant's pot, but the other plant pot didn't have any. So that's something that she did, that she changed. Then she measures. She's going to measure something. She measures the growth of the plant every week for 5 weeks and records the results in a table. So, what is the independent variable? What did Maggie change? Well, one plant pot had a tablespoon of vinegar, and the other plant pot didn't have anything. So that is something that she changed. So that is an independent variable. Dependent variable is what she's going to measure. She's measuring the growth of her plants. Obviously, the height in which the plants grows, whether it's in meters or centimeters or whatever. She's measuring the growth. So whatever you measure in an experiment is a dependent variable. Control. What did Maggie kept the same to make sure that her experiment was fair? The size of the plants that she used at the beginning were the same. She put them in the same location, the same amount of sunlight. They were exposed to the same amount of sunlight at the same temperature, and they had the same amount of water. So these are the different variables that was being tested in the experiment. I hope this is a little bit more clearer because it can be very confusing. Right, let's try another example. Identify the independent, dependent, and control variables in the scenario below. Christian wonders if a heavier cart will roll faster downhill than a lighter one. So his hypothesis could be a heavier cart will roll faster, down a hill, or it could be the other way around. A lighter cart will roll faster down a hill. That's his hypothesis. That's something that he can test. That's something that he's predicting. Okay, where am I? He formulates a hypothesis and then decides to conduct an experiment. First, he finds a smooth ramp and a cart. He makes sure that the wheels of his cart roll freely. He set the ramp against a chair, so one side of the ramp was 0.5 meters off the ground. Okay, so that's where the ramp was. It was 0.5 meters off the ground. Next, he measures the distance the cart will travel down the ramp. So the height of the ramp from the ground to the top were the same, and the distance that the cart is going to travel was also measured. He leaves about 10 cm at the top of the ramp and draws a line to mark the release position of the car. Okay, so he's got a line there somewhere on the ramp, so he knows that, at this line, I will be releasing, the car. So he starts the experiment by measuring the time it takes the cart to roll down the hill without any weight on it. So first, he let the car go to decide, what's the time that this cart will take to roll down this hill with no weight on it. For the next 5 trials, he adds 1 kg mass to the cart each trial. So now this is something that Christian is changing. He is now changing the mass that the cart is carrying. Good. The times of the trials were, these are the times, 1, 27 seconds, and so forth. So different times, okay? He was measuring it, the trials. When comparing the data points, he decides to allow for a 5-second fuge factor, since he may not have released the cart at precisely the exact same spot each time. All right, so he makes sure that he waited there a little 5 seconds just to ensure that the timings were fair. He finds that adding mass to the cart does not affect the time it takes to roll down the ramp. So, what's the independent variable? What did he change? He altered the mass carried by the cart. Different times, okay? He altered the mass. So before, at the beginning, remember, he released the car down the ramp with no mass on it. Then he added 1 kg of mass to the cart in each of his trials. So that's something he altered. Because he altered it, because he changed something in his experiment, he changed it, that'll be the independent variable. Now, oops, don't know why that's coming up. Now the dependent variable was the time and the distance traveled by the car. So he's measuring the time it takes for the car to move from the top of the ramp all the way to the bottom. So because he wants to see how long, it's going to take, he's measuring time. And he's also measuring the distance that's traveled by the cart at that time. So that would be a dependent variable. And control. The surface area of the ramp was smooth. He didn't change the surface area, because if you're trying to find out how fast the cart is moving down the hill, you have to ensure that the surface area is the same, because a slippery surface will obviously have less friction, and the car will move faster. or on a bumpy surface or on grass. The surface that the car is moving down the ramp has to be the same. He used the same cart each time. He did not, use a cart and then he used a truck and then he used a bicycle. Okay? It was kept the same. Now, also the height of the ramp above the ground was also kept the same. So as you can see in every experiment, you usually have a few control variables, at least 3 that you can measure, that you can say that you kept the same. Sorry. So in every experiment, you usually have a few control variables, and these variables are variables that are kept the same. So I'm going to ask you to read the last scenario and identify the independent, dependent, and control variable in this scenario. And you can send me a message on Google Classroom to tell me if you were able to figure this scenario out. So begin, please. You can pause the recording. Right, welcome back. Al wonders if adding salt to water will affect how long it takes the water to freeze. Al thinks that salt water will freeze more quickly than fresh water. So that's his hypothesis. His hypothesis could have been that salt water freezes more quickly than fresh water. That's something that's testable, and that's something that he's predicting, okay? He decides to check his hypothesis by conducting an experiment. So now he's going to conduct his experiment. Al takes 2 ice trays and filled one with distilled water and the other with distilled water that has 2 tablespoons of salt. You see, right then and there, we're going to stop there. One ice tray was filled with distilled water only, but the other ice tray had 2 tablespoons of salt. That is something that Al changed, that he changed, because something was changed, something was altered in experiment. That alone should tell us what variable that is. Now let's continue. He makes sure he puts exactly the same amount of water in each tray. So each ice tray had the same amount of water. You have to think, what is the name of the variable that is kept the same? Now, Al takes the tray and puts them side by side in the freezer. So again, they were in the same position in the freezer. Now, Al checks the ice trays every 10 minutes to see if the water in each tray has begun to freeze. Al finds that after 20 minutes, the water in the ice tray without the salt has started to form ice, while the ice tray with the salt is still completely liquid. Now, the independent variable, what did Al change? Well, one ice tray had salt added to it. That's something he changed. One ice tray had salt added to it. You could also say that the other ice tray had no salt added to it. Because Al changed that, that is considered to be the independent variable. So, what was Al measuring in this experiment? He was trying to measure the time it takes for ice to freeze. So, because he was trying to measure the time it takes for this ice to freeze, that will be the dependent variable, because that's what he's measuring, the time it takes for something to happen. And the control variable, again, you can have a few things here. The same amount of water was used in each tray. The same position, the trays were placed in the same position in the freezer. Again, because that was kept the same, that's a control variable. Here, you could also say that the checking time, he checked every 10 minutes. So he checked the same time. His checking time was the same. He didn't check in 2 minutes, then 3 minutes, then 4 minutes. He kept his checking time, his time interval of checking the same, because he checked every 10 minutes. So that was another control variable that you could have added. So I hope you understand more about the variables that are tested in each experiment. Remember, independent variable is whatever you change. Dependent variable is what's being measured. And your control variables are variables that will remain the same. And your task for this lesson: design your own experiment. Make a video or a poster. You can make a video of an experiment that you are testing or conducting, or you can make a poster about the experiment. When you finish making your experiment, you need to state the independent, dependent, and control variables in the experiment and upload your work on Google Classroom. I'm so eager to see what you can produce. This gives you the opportunity to use your creativity, and that's what learning is about. Use your ideas to formulate your own hypothesis and to conduct your own experiment. And just a quick reminder that do not forget to complete the end of topic 30-mark quiz. You have a multiple choice 30-mark quiz that's based on all the topics that we have covered for this term. And it's mandatory that you complete the quiz. I think this quiz is due on Friday as well. And do not forget to submit your work for today's lesson. Okay? The expectation is that you submit your work before the given deadline. And with that being said, I am Miss Burnett. Stay safe and enjoy.